remodeling. Bone remodeling is a process of formation and destruction of bone. Both are happening simultaneously at the same time in your body, in your skeleton. I mentioned it in last class. Both destruction and what? Formation. Both are happening what? At the same time, right? In early part of your life, formation is more than what? Destruction. That's why bones grow, right? Get bigger. Formation is more. In old people, which one is more? Destruction is more than production, right? That's why bones shrink, get small and weak, right? So that is bone remodeling happening throughout the life, entire life. But in early part, one is more than other. In late part, another is more than the other. Makes sense? And now you tell me, if I ask you, who helps to produce the bone matrix? Osteoblasts, young cells, right? And remember another type of cells I mentioned in last class, giant cells. They have many nuclei and mitochondria. They love to do what? Destroy the matrix, right? So opposite action. Osteoblasts produce, and osteoclasts, those giant cells, do what? Destroy. Okay? So both are there. So by the action of those cells, right, bone remodeling is being happening. Hormones. I mentioned that two types of hormones. One type of hormones help to grow, so help bone growth. Another type of hormones regulate calcium. Regulate calcium in the blood. So these are two types of hormones work on the bone. Which hormones help to grow the bones? Number one is, you all know that. Have you heard this name, growth hormone? All of us, we know growth hormone. And that is number one, comes from pituitary. Okay. And then another is thyroid. Another is vitamin D. This is although not a hormone, but a chemical, vitamin D. These three things, growth hormone, thyroid hormone, and they mentioned sex hormones too. Okay. Also, sex hormones. Okay. Help to grow the bones. Growth hormone is secreted more during the growth of the body in the early part of life, and that's how you see the kids grow fast, and works mainly on the bones and skeletal muscles. Skeletal muscles, okay? Thyroid hormone actually stimulate the growth hormone to work more. So thyroid hormone doesn't directly work on the bones or muscles, work on the growth hormone and modulate the activity of the growth hormone. Okay? But growth hormone directly works on the bones and the muscles to grow them. sex hormones. You all know that at puberty, when sex hormone production starts, right, kids suddenly grow, right? Within few years, you'll see the growth. So we know that sex hormones also stimulate the growth of the bones. And vitamin D, more vitamin D, that means more calcium deposition, that also helps in the growth of the bone. Now, the hormones help in calcium regulation, regulation of calcium in the blood. One hormone is called parathyroid hormone, or PTH, comes from parathyroid glands. Another hormone is called calcitonin, that comes from thyroid. Remember, parathyroid hormone comes from parathyroid gland. That is very simple. Calcitonin comes from thyroid gland. Thyroid gland. And calcium, vitamin D also works here. Vitamin D does what? Helps in calcium absorption in the intestine. You know, the food you eat that has calcium, and from the intestine, vitamin D helps to absorb the calcium into the blood from the intestine. That means from the food you eat. Okay? So, now, parathyroid hormone, remember, this is very important. Parathyroid hormone increases the calcium. Calcitonin, just opposite, decreases calcium. And vitamin D, more vitamin D means more absorption in the intestine. That means that will increase the calcium in the blood. Okay? So these two work in opposite way. Parathyroid hormone increases the blood calcium, calcitonin lowers the blood calcium. Okay? And by the action of these two, your blood calcium is maintained. Now, the concentration of calcium in your blood must be between 9 to 11 milligram per 100 milliliter of blood. In your blood, this is the normal concentration of calcium. Very important. Calcium concentration must be between 9 and 11. 9 to 11. Yes.
Growth hormone is producing. Which organ produces the growth hormone?
Growth hormone comes from pituitary gland that I mentioned here.
Oh, okay.
Yeah.
Oh.
Pituitary gland. Okay? In the brain. Okay. Now, if the calcium goes below 9, that is called hypocalcemia. Hypocalcemia. If the calcium concentration goes above 11, that is called hypercalcemia. Hypocalcemia can cause paralysis of your muscles. Muscle paralysis, yes. Yes, if it goes below 9, low calcium in the blood, that is called hypo. Hypo means less. Calcemia. And goes above 11, hyper. Okay. And hypocalcemia can cause paralysis of the muscles. And you know, if respiratory muscle paralysis occurs, right, you won't be able to breathe. And sometimes patients die in hypocalcemia. The person may die due to respiratory failure. Uh, Hypocalcemia can also cause tetany, convulsion, okay, seizure. Hypercalcemia often causes stone in the kidney stone formation, gallbladder stone formation. The last thing, how the calcitonin and parathyroid hormone work. Parathyroid hormone or PTH increases the blood calcium, you already know, increases the blood calcium. How? It works on 3 organs, works on bones, kidneys, and intestine. Okay. Parathyroid hormone stimulates the osteoclasts, giant bone cells, you must remember. Okay, now you tell me, osteoclasts love to do what? Destroy the matrix, right? And matrix contains a lot of calcium phosphate, remember that? Mineral. So, parathyroid hormone stimulates the osteoclasts. So, osteoclasts destroy matrix, and releases calcium from the bone. And this calcium enters into the blood. So blood calcium goes up. Very simple. This one you can easily understand. Parathyroid hormone increases the calcium in the blood, right? So tell me, everybody, should it let the kidney excrete more calcium or preserve the calcium to increase the blood calcium? Should it let it get out from the body or keep it in the body? Keep it in the body. Makes sense? If it gets out through the urine, then calcium will further go down, right? So, parathyroid hormone on the kidneys preserve the calcium, not let the calcium get out through the urine. Is it clear? So that is called reabsorption of calcium. That term, you need to remember this. Reabsorption of calcium. That means preserving the calcium, not letting it get out through the urine. That is reabsorption. And parathyroid hormone stimulates vitamin D. Now you already know vitamin D, I told you here, increases the absorption of calcium from the food. Absorption of calcium from the food in the intestine. So blood calcium will go up. If more calcium is absorbed from the food, calcium in the blood will go up. Okay? So it works through vitamin D. So these are 3 ways parathyroid hormone increases the calcium in the blood. Okay? The last thing, calcitonin does opposite, lowers the calcium. Okay? Now you tell me, calcitonin should stimulate the osteoclasts or inhibit them? Inhibit, right? We'll tell them, don't break the matrix. Don't break the matrix. Make sense? So suppresses or inhibits the osteoclasts. Tell them sleep. Okay? Don't be active. So matrix will not be destroyed. Calcium will not be released. Calcium will not enter into the blood. Blood calcium will stay low. Okay? That is. In kidneys, calcitonin will just do opposite. Tell the kidneys excrete more. Excrete calcium, right? So calcium in the body will will go down. Make sense? It's just opposite. Calcitonin works on these two, not here. Parathyroid hormone works on all these three. Okay? So that is the difference. And calcitonin comes from thyroid, PTH comes from parathyroid glands. Okay. Calcium is a very important chemical. It helps in many things in your body, and very important things. Transmission of nerve impulses, muscle contraction, blood coagulation, and secretion from the glands and cell division. So these are some important functions of the calcium. So if in your blood calcium concentration is low, then muscle contraction will not occur. It will cause paralysis of the muscles. Blood coagulation will not occur. Blood clot will not be formed. Bleeding will be prolonged. Okay? This is how I told you osteoclasts breaks the matrix and release the calcium into the blood. Fracture of the bones. We name the fracture by the location or by the type of fracture, the appearance, looking at the appearance and location. I'll just mention few different types of fracture of the bones. This is one type of fracture that is called comminuted type fracture. What happens here in this type of fracture, you see not a single fracture. In that area, you see multiple fracture. Here, right? Multiple fracture in the same area. This happens more in older people, aged people. This is called comminuted type fracture because bone is very fragile. Compression type fracture. Due to vertical pressure, you know, your spine, vertebral column transmits the body weight. Remember? Vertebral column transmits the body weight. So, if too much body weight, weight you carry on your head, or if you jump from height and land on the ground, pressure will fall this way, right? Vertical pressure that can crash the body of the vertebrae. That is compression type of fracture. Spiral fracture. Spiral fracture is only one fracture you see here, but oblique, not transverse, not like this. Oblique fracture, okay, like this. And this occurs mainly due to twisting like this. If I hold the bone like this and twist like this, that kind of fracture, spiral fracture occurs. Epiphyseal fracture. How many of you remember when I talked about endochondral ossification bone formation? Remember I said a thin plate remains, right? Between the end and the shaft. That is a weak point, right? Will never be converted to bone. So that is a weak point, easily break can occur. Right? That is the epiphyseal fracture at the epiphyseal plate here. Depressed fracture. If you see, after the fracture, the broken piece of bone has gone inwards. That is depression or depressed fracture. Best example you see their picture. If something hits the skull, right? The broken piece will go inwards towards the brain, right? So that is depressed. Happens in many cases, earthquake or road accident can cause that. Green stick. This occurs in young kids. Incomplete fracture. You see, not complete fracture, incomplete partial fracture, and from from the main fracture, multiple branches, you see. So that is called the green stick type fracture. Mainly happens in young kids because their bones have more flexibility, so it will not break completely. Make sense? Partial break, and from there see the branches. So these are few different types of fractures. Now, after fracture, how the healing occurs? Here, the bone fracture has occurred, you see here. Bones have blood vessels, you already know by now. So, rupture of the blood vessels will cause what? Rupture of the blood vessel will cause bleeding, right? So, blood will accumulate in that area, make sense? And that is called hematoma. Hematoma. Accumulation of blood. Makes sense, right? Next, what will happen? The gap will be filled by fibrocartilage. Not bone, fibrocartilage. That is called fibrocartilaginous callus formation. And new blood vessels will be formed in that fibrocartilage. New blood vessels will be formed. Then fibrocartilage will be converted to bony callus, bone tissue. Will convert it to bone tissue, bony callus formation. And then remodeling of the bone will occur. Now what is that? When you see the fracture is healing, if any of you had fracture before, when the bones join, you'll see that area is rough. If you feel that area has bump, right? Rough, excess bone tissue is still there. So it is like that, you know, if you see a hole in the wall of your house, right? What you do? You buy that white thing called what? Skeletal? What is that? The cement, white cement?
It depends. It could be caulk you're talking about.
Yeah, caulk, or yeah. You fill that first, right? You just roughly fill it. Then let it dry, right? And then, if the surface is rough, you do what? Sandpaper, right? You use to polish it. Excess, you know, thing you remove from there. Same thing happens when two, you know, broken pieces join together by new bone tissue. That surface is rough. Make sense? So, who can break the bone? What type of cells? Osteoclasts. Remember that? So, osteoclasts will now work there as sandpaper to break excess bone tissue, right? To make it smooth. That is the remodeling. Make sense? So, those are the steps of healing of the fracture. Okay. Rickets. Bowing of the leg bones. You will see in many kids. If you go to third world countries, here we don't see. I never saw any. But if you go to Africa or less developed countries where kids don't get enough calcium-rich food or vitamin D-rich food, what happens? Their bones get weak because of lack of calcium. Make sense? So the leg bones bend because of body weight, and that is bowing of the leg bones. That is the rickets. Okay. Why leg bones? Because body weight is transmitted through the legs, right? Not through the hands. So leg bones. Inflammation of the cartilages, soft tissue in the joint is called rheumatoid arthritis. Inflammation of the soft tissue like articular cartilages, that is rheumatoid arthritis. And osteoporosis occurs mainly in older women. due to lack of what? Estrogen, female sex hormone. Okay, when the female sex hormone secretion decreases, that causes osteoporosis. Osteoporosis, many tiny holes in the bone, pores or holes. That's why called osteoporosis. The bones become very weak and fragile. Here you see the spongy bone in healthy bone, normal, and this is osteoporotic bone. You see many tiny holes. So this bone is really very weak and easily will be broken. Okay. So those are a couple of clinical conditions occur in the bone tissue. Okay. Do you have any question?